Here's a clever experiment that reads 3 hidden things off one jagged graph: how much the battery resists, how fast sodium moves inside, and its calm resting voltage. It's called GITT, and the trick is simple: poke, then wait. We push a small current for a few seconds, then stop and let it rest. Watch the voltage. The instant we push, it jumps down sharply. That sudden jump is the ohmic resistance. The bigger the jump, the more the battery fights the current. So the size of that jump you can read straight off. It is the ohmic resistance. Now we stop and wait. The voltage slowly drifts back up and settles. Why slowly? Because the sodium inside needs time to spread out evenly again. A fast settle means sodium moves easily. A slow, lazy settle means sodium is sluggish. So the shape of that relaxation tells you the diffusion, how fast sodium travels. Now repeat this poke and wait, again and again, working through the battery. You get this staircase, and here's the gift. Connect the calm resting points, and you trace the battery's resting voltage, its OCV. Rest long enough between pokes, and it approaches the true equilibrium voltage with no resistance hiding it. So one jagged graph, 3 readings. The resting dots give the OCV, the jumps give the ohmic resistance, and the slow relaxations give the diffusion. So GITT is just poke, then wait. The jump is ohmic resistance. The slow relax is diffusion. The resting points give the OCV, a jagged little line that quietly hands you the battery's inner secrets.